The cosmic web is a prominent and fascinating theoretical concept in astrophysics and cosmology. It describes the large scale structure of the universe, where galaxies and galaxy clusters are organized into a vast interconnected network of filaments, walls, and voids. One theory about the formation and evolution of the cosmic web is the cosmic web formation by gravitational instability. According to this theory, the cosmic web's formation can be primarily attributed to the gravitational instability of matter in the early universe. Here's an overview of how this theory works. Initial density fluctuations in the early universe. Shortly after the Big Bang, the density of matter was not perfectly uniform. There were slight density fluctuations, with some regions being slightly denser than others. These fluctuations are thought to have originated from quantum fluctuations during cosmic inflation. Gravitational attraction over time, the regions with slightly higher density began to exert a stronger gravitational pull on nearby matter. As a result, these regions attracted more matter, leading to the accumulation of mass in those areas. Filament formation. As matter was drawn towards the denser regions, it started to form elongated filaments connecting these regions. These filaments act as skeletons of the cosmic web, and their formation is driven by gravity. Void formation, in contrast, regions with lower density became underdense voids because they had less matter and weaker gravitational attraction. These voids exist between the filaments and walls of the cosmic web. Wall formation. In addition to filaments and voids, walls or sheets of galaxies and dark matter formed in intermediate density regions. These walls separate the cosmic voids and contribute to the overall structure of the cosmic web. Galaxy and cluster formation. Within the filaments and walls, galaxies and galaxy clusters formed as matter continue to accumulate in regions with higher density. The cosmic web therefore serves as the scaffolding upon which galaxies and galaxy clusters are situated. Evolution over time. The cosmic web has evolved over billions of years. Gravitational interactions between galaxies, dark matter, and dark energy have continued to shape its structure and dynamics. This theory of cosmic web formation by gravitational instability is consistent with our observations of the large-scale structure of the universe, as seen in galaxy surveys and cosmic microwave background radiation measurements. It highlights the fundamental role of gravity in shaping the universe's structure, leading to the intricate and visually striking cosmic web that we observe today. The size of the cosmic web can be enormous, spanning vast distances across the universe. The scale of the cosmic web is primarily determined by the largest structures within it, such as superclusters of galaxies, filaments, and voids. Here are some approximate size ranges for these components. Filaments. The cosmic web's filaments are among the most prominent features and can be hundreds of millions to billions of light years long. They connect galaxy clusters and groups, serving as pathways for matter to flow across the universe. Voids. Voids are immense, relatively empty regions of space surrounded by filaments. Their size can vary, but typical voids can be tens to hundreds of millions of light years across. Superclusters. Superclusters are the largest structures in the cosmic web. They consist of multiple galaxy clusters and can span hundreds of millions of light years. Some well-known superclusters, such as the Shapley supercluster and the Sloan Great Wall, are incredibly vast. It's important to note that the cosmic web structure is hierarchical, with smaller filaments and voids nested within larger ones. As a result, the overall structure of the cosmic web is a complex, interconnected network of these elements, and the scale of the cosmic web is truly mind-boggling, reflecting the immense size and age of the observable universe. The cosmic web is not ending from the universe in the sense that it has a finite boundary or an edge beyond which it does not exist. Instead, the cosmic web is a large-scale structure that permeates the entire observable universe. It extends indefinitely, connecting galaxies, galaxy clusters, filaments, and voids on cosmic scales. And the concept of an ending or boundary to the universe is a bit more complex and relates to the broader question of the universe's overall structure and its boundaries. According to our current understanding of cosmology, the universe appears to be both infinite and unbounded. In this view, there is no specific edge or endpoint to the universe. It extends infinitely in all directions. However, it's important to note that our observable universe has limits. Due to the finite speed of light and the age of the universe, there's a cosmic horizon beyond which we cannot observe objects or events. This observable universe has a cosmic edge in the sense that we cannot see beyond a certain distance. Nevertheless, the universe itself is believed to be infinite and unbounded. The cosmic web is an integral part of this infinite universe, and it continues to extend and evolve on cosmological timescales. While the observable universe has its limits, the universe as a whole is thought to be limitless and unending. The cosmic web is not inherently colored purple. Color of the cosmic web you may see in visual representations or simulations is often chosen for visualization purposes and is not a property of the cosmic web itself. Choice of color is primarily a matter of aesthetic preference, contrast, and to help make the structures more visually distinct in scientific illustrations and educational materials. Purple is a commonly used color for depicting a cosmic web because it provides good contrast and stands out against the background. It is not intended to represent any specific physical property of the cosmic web. In scientific contexts, various colors may be used to represent different structures or physical properties in simulations or visualizations, but the choice of color does not have a fundamental scientific meaning. In reality, the cosmic web is composed of galaxies, dark matter, and gas distributed throughout the universe, and it doesn't inherently possess a color. Its structure and properties are usually studied and represented through data, simulations, and visualizations that use colors for clarity and ease of understanding. The cosmic web is a vast and intricate network of large-scale structures in the universe composed of filaments, walls, and voids. It contains a significant number of galaxies distributed within these structures. The exact number of galaxies in the cosmic web is challenging to determine precisely because it depends on various factors, including the scale of observation, the region of the universe being considered, and the density of galaxies in different parts of the cosmic web. However, to provide a rough estimate, it is believed that there are hundreds of billions, possibly trillions of galaxies in the observable universe. These galaxies are not evenly distributed, but tend to cluster in filaments and walls within the cosmic web, while voids have relatively fewer galaxies. The exact count depends on the volume of the observable universe being considered and the level of detail in the observation. It's important to note that our estimates of the number of galaxies continue to evolve as our observational techniques and telescopes improve, providing us with a more comprehensive understanding of the universe's large-scale structure and the distribution of galaxies within the cosmic web. The question of whether there is other life in the cosmic web, or more broadly, whether extraterrestrial life exists in the universe, is one of the most profound and unanswered questions in science and astronomy. As of my last knowledge update in September 2021, there is no direct evidence of extraterrestrial life, and scientists have not yet made contact with or discovered any conclusive evidence of life beyond Earth. However, it is essential to consider the vastness of the universe. The cosmic web spans the observable universe, and it contains countless galaxies, stars, and planets. With the sheer number of celestial bodies in the universe, it seems highly probable that there are other habitable planets similar to Earth. In the quest to find extraterrestrial life, astronomers focus on identifying exoplanets, planets orbiting other stars within the habitable zone where conditions might be suitable for life as we know it. The search for extraterrestrial life involves efforts such as the study of exoplanets, the search for biomarkers in the atmospheres of distant worlds, and the exploration of places within our own solar system like Mars and some of Jupiter's moons for signs of microbial life. While no definitive evidence has been found to date, the search continues and our understanding of the cosmos is continually expanding. The cosmic web, being a framework for the distribution of galaxies and structures in the universe, is not directly related to the existence or non-existence of extraterrestrial life. Whether or not life exists elsewhere in the universe remains an open and fascinating question that future scientific discoveries and space exploration missions